Well, 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 look what we got here. Yes, look at me. I'm the new Falcon F16V4. I support more pixels than everybody, and I wrote my software. All right now, don't have to start with the smart mouth. Come on, old man, show me what you got. Matrix slow-mo fight. So fast it's all blurry. Slow-mo roundhouse kick. Slow-mo power driver. And hey, no cameras in here. Hi, welcome to Canispater Christmas. This video is sponsored by the fine folks at pixelcontroller.com. And what I wanted to do in this video is take a look, kind of compare the difference between the F16V3 and the brand new F16V4. Now, they've been out for at least a year, but supply issues and all that kind of stuff. So, there's not a whole lot of difference, as you can tell. The main thing is that this was a processor and an FPGA, and now we just have a dual core processor. But that's a big deal. A couple of other things have changed around, so I'll take a closer look at this. All right, the first thing I want to do is take a Captain Obvious look around the two different boards, comparing the V3 and the V4. Upper left-hand corner, we still have the Wi-Fi module and the OLED display, along with the buttons for manipulating the menu. We have the two Ethernet jacks. On the V3, it's labeled ETH0 and ETH1, and on the V4, it is just network. It really doesn't matter which one you plug into there. The USB connector on the V3 has been removed from the V4. We didn't have a use for it. It's out of here. The SD card holder has been moved on the V4 down a little bit and replaced with the fan connector, which was under the analog inputs on the V3. The analog inputs are a little different. The big difference on the V3 is a single connector for expansion cards, whereas on the V4 we have two separate connectors for the expansion cards. On the upper right-hand corner of the board, there are three outputs, both on the V3 and the V4. However, on the V3, output number 1 had all 4 serial ports, and you could use a differential receiver with that. 2 and 3 were LOR DMX outputs. Now on the V4, 2 outputs are receiver 1 and receiver 2. And the third one is a DMX LOR output. The input power selector has changed from 2 jumpers to a switch. And the external power connector above V2 has changed from a jumper to a switch. And the only other big difference on these are the output resistors. There's 8 of them across both boards. On the V3, they are 100 ohm resistor networks, and on the V4, they are 33 ohm resistor networks. All right, so here's the setup. I have a 12 volt power supply. I have 12 volts running into the board. Now, don't do this, for display purposes, but on the bench you can power the board this way. Normally the power comes in this V2 connector. Anyway, we've got power coming in to power the electronics. Then I have a wire coming out of here, and all we're using is data off of this. You notice that there's no power connection here. So we're just pulling data off. It's coming around. It's coming through this set of pixels. And I have another power connector coming out of here, and it's going into the last pixel. So this is pixel number 100, and so power is coming straight in there. I'm not taking any power off of the board right now, and I'm doing that so that voltage drop does not factor into our little test here. So what I'm going to do, and I have a little sequence, basically ramps up, and then we have a long ramp. So this is going to 100%, and so if we start seeing any problems at the 100% level, then we know that's pretty much where we're going. So I just cut off the end of a 10-foot cable and put this pigtail on there. So data is coming through here, going into the first pixel, and then we're getting power from the back of the string to eliminate voltage drop. So all we're testing here is signal degradation through extensions. So I'm going to start adding extensions to this and see how far I can get. And this is the F16V4 that we're running this test on. So I've got 1, 2, 3, 4, 5, 60 feet of cable, and it still looks great. All right, so we got 7, and we're getting some flickering. So we'll call it about 60 feet that we can go from an F16V4. All right, same setup, but on the F16V4 this time. Got power coming into port 16. I got the data coming off of port 1. Same 70 feet of cable, but this time we are not seeing flickering when it gets to 100% white. So let's start adding cables and see how far we can go. Okay, it took a little while, but I finally got some flickering from this. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 140 feet. So it actually basically doubled the point to where it's flickering. So the F16 started, the V3 started flickering at 70 feet, and this one started flickering at 140 feet. That's pretty impressive. So now look, I understand this is not, this is laboratory conditions. You're probably going to get killed by voltage drop before you get that far. And for those of you wondering if it's possible, I put one of the V4 resistor networks into the V3. Remember the 330 and what is these, the J101. So I have 130 feet of extensions, and it looks like we are not getting any flickering from that distance on the V3. The V3 and the V4 are powered the same way, so you have power coming in here for these 8 pixel ports. You have power coming here for these 8 pixel ports and the electronics. You want DC voltage here. You don't want AC mains power coming in. So you need something like this, a power supply. This plugs into the wall. This is where your AC or mains power comes from. And then this is the DC side that connects to the board. You don't want to connect up a pigtail like this directly to this. Otherwise, you'll be very unhappy, and everybody else will be very unhappy because you won't have a display. V1 and V2 have these little gates in them, so you go left to loosen and the little gate goes down, Then you put the wire in there, and then you tighten it up until the little gate comes up. So let's put a wire in there. I always try and just take them down just so I don't have to deal with messing with it. It's ground. And this is hot. So there we go. We have applied power, and you'll know into V1 only, and so these 8 lights are lit up, meaning that power goes to these 4 outputs. Now the problem is the board is not on. If you can't see any of the little LEDs are on, the OLED isn't on. Well, that's because power comes on this side. So let me connect power to this side, and the board should light up. All right, so I moved power over to V2, and you'll notice that it is opposite V1. So this is ground and plus, and this is ground and plus. So that's outer is ground, in is plus. And you'll notice that again, we only have 8 fuses lit up. That's because now this side of the board, I'm going to cover that fuse. This side of the board is now powered by V2, plus the board electronics are powered by V2. So now we got the OLED, we got the Wi-Fi, and we have these LEDs going. Does that mean you can power the board with 2 different voltages? Yes, you can. You can put 5 volts over here and 12 volts over here, or 12 volts over here and 5 volts over here. The only caveat there is if you're running 5 volts on V2, this powers these 9 through 16. And if you have an undersized power supply, the board may spontaneously reboot, because you know when you're hitting it hard, all the lights are on, and we're pulling a lot of power from that supply. If it's not adequate enough to handle the the power draw, then the board may reboot. So in that case, you've got a couple of options here, or you have one option. Well, you could go in with 12 volts. Your pixels wouldn't like that, so you'd have to move everything around. You can go in with 5 volts, an external 5 volt supply, just to provide power to the board, and that should take care of that problem. If you do that, flip this switch up, and it'll take power. The board will take power from this input here. Also, make sure that you get the voltage setting correct. If you're going with 5 volts, you want to go that way. If you're going with 12 volts, you want to go this way. So my switch is going that way because I'm going with 12 volts. If I had 5 volts, flip it the other way. Do not put it in the 5 volt position and power it with 12 volts, otherwise. If you always start out with 12 volts, you probably won't have any problem. You come in with 5, it's not working, you're like, oh, I don't understand what's the problem. Oh yeah, 5 volts, but it just won't work. If you start off with 5 volts and you hit it with 12 volts, as on the V3, the V4 also has a real-time clock battery slot under the OLED here. Now you need to put the battery in before you set up the real-time clock. Once you're done for the season, take the battery out, because it's just going to run down if you don't. All right, the board has 2 Ethernet connectors, and actually these are RJ45 ports. These are not network, they are something else I'll get to in a minute. But this is where you come in or go out with data. Like if you have Falcon Player running, or you have Xschedule running on a PC, you can come into one port, and then if you just have one controller, that's fine, you're done. If you have another controller, you can come out of this next port and go onto the other controller, or you could come into this port and then go from here out to the, it doesn't matter. You can use either one of these connectors to come in, and then the other one to go out if you want. Doesn't matter which one. Do not use these for Ethernet connection, otherwise actually it just may not work. These are not Ethernet connectors. These are for well, one's DMX and the other two are for differential receivers. We'll get to that later. This micro SD card slot, you can use it to update the firmware. You can use it to hold sequences, audio, playlists, schedules. You don't need it if you're just using this as a, you know, controller. You only need it if you're running this as, say, a remote Falcon player or a standalone controller or something like that. But if you're feeding data into this, you really don't need the micro SD card slot populated with micro SD card. Okay, these four connectors right here are the input connectors. They allow for push buttons or sensors or other triggers to be utilized. You basically can short the two pins together to have a trigger. The 16 pixel output ports, these green things, they're for connecting up pixels to. It goes ground or V minus, clock, if you have 4-wire pixels. Most of you are running 3-wire pixels, so you don't use the clock pin. Data, and then voltage plus, or plus 12 or 5 volts, whatever you're using. So ground, clock, data, V plus. That's how you wire this up. For a long time we said it's 1024 pixels per port, but there's some caveats there, kind of like Ethernet cable. Okay, you can do 1024 but you can only do that at a frame rate of 20 frames per second. If you want to go to 40 frames per second, you want to keep that under 704 pixels, I guess. I've always heard about 680-ish, you know, it's kind of that. The manual says 704 pixels before it'll actually switch to 20 frames per second. So if you're not getting 40 frames per second, maybe your strings are too long. At 1024, you're not going to be able to power 1024 pixels off of one of these ports. These fuses are only 5 amp fuses, so you're going to have to do power injection on a string that long. And we're not going into power injection in this video. You may be able to get like 55 volt pixels or 112 volt pixels, maybe even 125 12 volt pixels. Really just kind of depends on the pixels, how much power they draw. You can't exceed 5 amps. You go over 5 amps, actually no, it'll just blow the fuse. This controller only supports what we call smart pixels or digital pixels. Pixels that control their brightness and color using digital data. Older technology was, they call them dumb pixels now. They had 4 wires. They determined the color of the entire string by varying voltage on those 4 wires. So those types of pixels are not supported by this controller. If you are using this in player mode or master mode, you're basically originating all your data from this. There is an audio connector right here. I wouldn't use it in remote mode because this is going to go up and down, but there's an audio connector right here. You can get a separate audio board to take that audio and pipe it to speakers or FM transmitter, or whatever you want to do. The fan connector is right here. If you have this in an enclosure and you want to put a fan on it, you can do that. If you have 5 volts connected to V2, a 12 volt fan will not function. If you have 12 volts connected to V2, using a 5 volt fan may be a problem. So these are the 2 expansion connectors. Now, if you're only using 1 expansion card, use 1. Don't use 2. If you're using 2 expansions, well, then you'll have to use 2. But plug into this one because the ports are set. So if you have one of these, it determines, it sets the which port these are based on which one you connect it to. But if you only have 1, plug it into 1. If you look, come on. If you look closely, there's a little notch or a little tang on the bottom. It's right there. You see it? A little extra piece of plastic, and it goes in to a little piece of plastic would go into here. This, if you're using 1. If you're using 2, you can plug it into there. But it only goes. It basically it only goes in one way, so you don't have to mess. You don't have to worry about getting in the wrong way, unless you're like a gorilla and you do put it in the wrong way and you jam it in there and you break the thing. It's not going to work. These are the serial output connectors. These top 2 are for differential receivers if you want to use those. This is DMX Lor and Renard. Only use this if you're going DMX Lor Renard. Do not connect them to here. Otherwise, and if you are using this bottom one, there's 3 little jumpers down here that you need to set either for LOR or DMX, depending on what you're going to. The F16V4 will not output LOR data. It outputs DMX data over the LOR pinouts. So you would need an LOR controller that accepts DMX for this to talk to it properly. And Renard users will need to use a special cable, typically made by you. Most Renard boards are DIY boards. You should consult your controller assembly or user manual to determine the pins used for your controller. And make sure you have these jumpers in the correct position before you start plugging stuff into here. You might damage the board otherwise. And obviously do all these changes while the board does not have any power connect. In other words, turn everything off, make your change, plug your stuff in here, and then you can power it on. Don't power it on and start pulling cables and changing jumpers and stuff. One expansion card is the 16 port expansion. It can handle a maximum, just like the board, of 32 amps total. It has 2 connectors just like the main board does. You can run different voltages, you know, like you can run 12 volts here, 5 volts here. You could run 5 volts here or 12 volts here, you know, either one. So half of it is powered by one connector and the other half is powered by that connector. This is the differential expansion card. So you can run strings of differential receivers off of here, and distance of 250 feet or roughly 75 meters. So that's a pretty long distance to go from here. You can run strings of 6 smart receivers. You want to use Cat 5, 5E, or 6 Ethernet cable between here and the receiver to get that distance. When the receivers are used in smart mode, you could hook up 24 differential receivers to this, 4 strings of 6. This board does have a power selection jumper, so if you only have one of these, then you can use the ribbon cable. If you have 2 of these, one of them needs to be powered with this external connector. don't change the jumper while you have power applied to the system. All right, I'm going to take a look at the configuration interface. It's basically you open a browser to the IP address of your controller. So I just type that into Chrome here, and this is the home page for the controller. It'll bring you on, this is the status tab. And if you have seen one of these before, then this is mostly going to be a review. But if this is your first time taking a look at it, then I'll go through most of the important points. I think most of this can be handled through X-Lights. In other words, when we get into the E131 configuration and the pixel output settings and the serial output setting, all that stuff can be programmed by X-Lights, and I highly recommend you learn how to do that. It makes all this so much easier than having to do this manually. Now you can, you know, once you set it up, you can save your settings and then load them back in. Like when you do a firmware upgrade or something like that, it's going to erase everything, so you'll need to have those saved off, or just reprogram it from X-Lights. We look at the board configuration here, and it's got several options, and it's basically what do you have connected to the F16. So is it just the 16 local ports? Is it the 16 local ports plus you're using the 2 smart receiver outputs? Do you have a 16 port expansion card? Are you running a 16 port expansion card and the 2 smart receiver outputs? This is the differential receiver or differential expansion board that has the 4 chains of possible receivers. The board, the differential expansion board, and the 2 output ports, the 2 chains. 16 plus 16 plus 16, so you have 2 16 port expansions connected. 16 plus 16 plus 4 is a 16 port expansion and a differential expansion. And then this is the opposite, where you have the differential expansion first and then the 16 port expansion. And the last one is 16 ports plus a differential expansion plus another differential expansion. And so you want to make sure that you set this up, because this affects some of the other tabs once you get in through here. There are a couple of these. I'm just gonna go with E131 Artnet, and what that means is basically the controller is accepting data on its Ethernet and sending data out to all the pixel ports. And kind of a standard configuration, maybe, I don't know. But there are other options here, so you can have it as just a standalone player, a remote. It can be the master. It can use DDP or ZCPP. And I'm not going to cover those. If you, real quickly though, if you're in X-Lights and you select Falcon as your board, you also have these same options here to set it up. So, you know, as you're creating your configuration in X-Lights, you can set all this here, and then when you write this configuration out to the board, all that stuff will be set up automatically for you. Well, not automatically, but it'll be set up properly. Let me put it that way. We have a test menu here, or a test tab. It's basically you hook lights up to the controller and you can have them turn on and just verify that, you know, connectivity is working. Input, these are the 4 inputs. You can have them do a few things here. So like if you go to reboot, hit save. Anytime you make a change in this web interface, you need to hit save. Otherwise it won't save it. And so this is reboot. So if I hit test, the controller will reboot. Now you're not looking at the controller, but my controller just rebooted. And we're back. So I'm going to get rid of that one because I don't want that. Hit save. So this is where you configure the 4 inputs if you're using those. Network, and this is probably the only tab that you need to set up outside of X-Lights, because it needs to get an IP address for it to be able to talk to the controller, or the controller needs to have an IP address before X-Lights can talk to it, because you have to enter the IP address. I am using DHCP here. DHCP is an automatic addressing scheme, and so it automatically picks up an IP address, and it displays it on the OLED. So if you don't know what the IP address is, just look at the OLED and it'll tell you what it got. If you're using Wi-Fi, you can set that up here. E131. So these are all of the universes that you want the controller to listen for. Again, instead of rolling these manually, I would highly recommend you use X-Lights to set that up. I'm going to skip recorder for now. Output settings, pixels. This is kind of where all your configurations will be. Again, let X-Lights do this for you. But you can set, you know, start universe, how many pixels you got. You can set some different parameters here. If you got a different color order, what direction you want it to be. Like if you set the string up backwards, you can go backwards, reversed. Brightness levels, you can change those. Gamma, you can change that. And I'm not going to go into a lot of detail on this one because it's probably more rarely used. And if you use it, you kind of probably have figured this out before. But I would, if you are going to use it and you don't know anything about it, consult the manual. There's good instructions in the manual on this one. And then settings. You probably won't need to do a lot of stuff here, if anything. I did set my time zone. So then we have the help page, if you need that, and then now the FSEQ recorder. Most of you won't use this. I mean, this is basically a feature that was added for Matrix users. Lets you play a sequence out to the network and then capture that as a file here, and then you can replay that file as a normal sequence. One other thing that pro users might be interested in, if you go to the pixel output settings page and click on this little thing, this shows you what pixels are supported. Gives quite a bit of information here, and let's see, I mean, most hobbyists are going to be using WS2811. 3 channels, 8 bits, blah, blah, blah. But there is information here for other pixel types. And you might notice right here where it says max pixels when 32 ports or less. So let me close this. When you had expansion cards added to the F16 prior to this, there used to be a little slider over here that would allow you proportion, kind of proportion things in banks. That's really kind of gone now. So if you, or no, it is gone, as you can see. But if you have 32 ports or less, you're allowed 1,024 pixels per port. Once you go over that, it limits it to 704. They do have a visualizer. This basically just shows you how much of the string has been used up. It doesn't let you, move props around or anything like that, but it's helpful if you've got, remotes and trying to figure out how many pixels are on different ports. So that is basically it as far as the web interface on the controller. You can go and set all this stuff up manually. Realistically, letting X-Lights do all this for you is much easier. And let me show you. Let's do something crazy here. So let's go to the layout. Add a new model. So let's add an arch. How about that? Okay. So we have arches. Okay, all that looks fantastic. I'm going to save this, but I'm going to go back to the controller, and we're going to visualize it now. So now you notice I have these strings and I have the new pixels. So the arches is what I just added. So we're gonna set that to port 1 on the controller. It's 50 pixels, and it shows here that we've got 50 pixels. So pretty cool. Oh, this is the PC. It's over here. Okay, so let's save that. Let's upload the output. Let's go over here and refresh the page. And looky there, it says arches, 50. All that stuff is set up properly. Now, what if we go back and visualize? Now let's set these new pixels. Oh, you know what? I'm gonna move the new pixels here and the arches there. Okay, so I've moved them around a little bit. You hit save, you upload the output. Now we refresh the page. Look at there. We got the new pixels on port 1 and we got the arches on port 2 now. Alright, so that is a quick overview of these two boards. I'm going to do other videos about looking into other things a little bit deeper. The remote, the standalone capabilities. I don't think I've even ever done a video on that, so that'll be kind of neat. It's a lot of functionality in this board. And then the expansion options as well. I probably want to dive a little bit deeper into that. So if you have any questions about this so far, leave it below and I will get back to you. Other than that, thanks for watching and I'll see you again soon.
Now I shot an email.
I got 6 of these, and so I got 5 of these. I am your father.